who does the sort of like preamble here? Is that me or is that you?
I mean, really, we should have like a little coordinated song and dance. But how about you give it?
Okay, yeah. So this is episode 2 of Jeff and Dom make a game. Uh, I'm Jeff.
And I'm
That's
Dom.
Dom. Yeah, and we are. Do we classify ourselves as professional programmers?
Yeah,
Maybe barely.
unfortunately, so we have like 15 years experience each or something. Like, I think
Yeah.
we have to at this point.
Okay, so we're barely professional programmers who are trying to figure out how to make a game, and you're going to see all the gory detail on this stream. Um, So I think for today, we are going to try to put together kind of the traditional first game project that I think most folks will try to make just if they're trying to teach themselves how to do things. This is a way for Dom and I to kind of learn how to make a game first. It's not the real game that we want to make necessarily, but we are going to be making Breakout today.
Hmm.
Um, so Breakout. I actually have never played a game that's called Breakout. I've played a game that's called Arknoid.
Hmm.
Dom, did you play Arknoid?
I played Arknoid, and I played so many things that were like Breakout, but nothing actually had that name. Yeah, we didn't
Yeah.
grow up in the '70s in an arcade. I didn't.
So Breakout, I would maybe call it an evolution over Pong.
Hmm.
The idea is you have one paddle along the bottom of the playfield. There's a ball bouncing around, and the ball will. There's a bunch of bricks in the playfield as well, and when the ball hits a brick, it destroys the brick. And generally, the goal is to destroy all of the bricks, right? So maybe a combination of Pong and pinball is the way that I would describe it.
Yeah, and picking up from last week, we've got manual Breakout here. I can bounce it off the walls purely by hand.
Yeah. So I think, Dom, one of the things that we did last time was we went through all the gory detail of doing the rendering in OpenGL,
Yep.
partly because we're masochists, I think. And
It
so,
was it was an experience. And then looking up the canvas docs to be like, how do we draw a rectangle with a normal canvas context is one line.
2 lines if you
If you want to pick the color, yeah.
yeah. Like fill rect, draw rect, I think is the interface, right? Something like that.
Yep, and then fun stuff like paths and lines and move to sort of flesh it out. So
yeah,
I'm excited to switch this to a 2D context and see what that gets us.
Right. So today's activity for the next couple of hours is gonna be maybe divided in between Dom and I just refactoring the code that we just wrote last week and basically chucking all of it to get our rectangles drawing again. And then we'll just try to build up the elements of a Breakout game. We'll get a ball bouncing around. We'll try to get a paddle drawing that's keyboard controlled and see if we can get those things to work together. And if we are super lucky, we'll also be able to render some blocks and maybe do some block collision as well.
Yep.
It's lots to take care of in 2 hours.
Sounds good. Yeah, we got a lot of OpenGL done in 2 hours last time, so without that roadblock, I bet we'll be chugging along.
True.
All right, so today I am the driver, and I think I'm just going to start deleting the OpenGL specific code. It's in Git, so we have it as reference when we need it.
Okay, that sounds good.
Yeah. So we're not going to compile any shaders. We're not going to link any programs. We're not going to make or use any programs. Rip. But I think we can hold under our vertices and indices if we want to. Well, no, it really doesn't.
No, we don't need those either. I don't.
Those are the triangles that we're not drawing anymore. Yep.
Yeah.
So down here is where I think it starts to get. We have our position, our speeds. Maybe I'll just put some comments on this. Oops. On our GL drawing code because this is where we're going to be putting draw recting instead.
Right.
Did I use something called size? Maybe I did. Let's just let size equals 1. Just to make that happy. Oh, good. I saved the file. The entire app went away.
Yeah.
That's how you know it's working. Okay, cool. So let's see. So I'm going to change this GL variable to context, since it's not actually real GL context. Canvas 2D context. Keep our error logging in there. And I guess we probably don't need this viewport. Yeah, does not exist on Canvas rendering 2D. Sweet.
Yeah. So on a 2D context, is there a distinction between like flood filling the entire canvas versus drawing rectangles, or would you implement the former in terms of the latter?
Oh, that's a great question. Let me take a peek at the canvas docs, but I'm pretty sure that you could maybe accomplish that by setting a background color.
Yeah, I'm kind of looking at the same thing.
Yeah.
Last time we were unable to solve the mystery of how our GL canvas was getting blanked every frame, because we definitely didn't have any code that was telling it to do that, right?
Correct. But we're hopefully not dealing with like quite the same OpenGL pipeline this time.
Yeah.
So at least the 2D context doesn't seem to have like a straight up like what is my background color, which kind of makes sense to me.
Yeah.
I like the concept of owning what is basically going to be our background. So like I think drawing that as a rect makes a lot of sense to me.
Okay, that sounds good.
Yeah. And so maybe we can start with context.draw. Is it canvas.draw? It should be the context.
It should be the context.
Yeah. Fill rect.
Fill rect. Yes, fill rect.
Mm-hmm. So we'll start at 0, 0, and we'll take our width and height. All right. That's back to where we were.
Yeah. So how does it know what color we're supposed to be using there? Does it default to black?
It seems like it does because fill
color.
Fill style.
Fill style.
Was there a fill? Yeah.
Hang on a sec. Let me. I'm on MDN as well over here. Fill style equals the string, which is your color.
Oh, it's a string. Good lord. So and it could be the string could be like it could be RGBA. Like it could be this as a CSS string essentially, right?
Oh, yeah. I see. Okay.
Because if I change that to 1, we should get black.
Maybe it doesn't know what it's doing there. What if you did a hex color, like a hash something?
It says fill style is not a function.
Fill style equals the string.
Equals, thank you.
Oh, I'm glad you're getting rid of my semicolons as well.
Only by the fact that I'll never type them myself unless an editor puts them in for me, so.
Yeah, I'm happy to get rid of the semicolons. Okay,
Great.
This is sweet. This is probably what we want, right?
Yeah.
It's a little bit unfortunate that this is a string, isn't it?
In what way? Like it's nice that we can kind of get into transparency here.
Yeah.
It seems to just be a CSS string, which is interesting.
Yeah.
But it gives us some flexibility at least versus just a hex color.
Right. What I imagine what will end up happening, we don't have to do this now, is when we get into the business of drawing the paddle, the background, and our blocks, we'll probably want a function that probably takes a series of coordinates or whatever and a color object and just draws the rectangle for us. But we'll cross that bridge when we get to it.
Okay. Yeah. Cool. And it's interesting. I'm expecting we'll have to maybe clear canvas to black. We might want to do this on every animation frame.
Yeah.
Because
why don't we see if it forces us to or not? We'll see.
Yeah. So my guess is that the 2D context clear takes whatever rectangles you give it and sets it transparent, which is like kind of useful, and maybe will inform how we want to think about the 2D pipeline for Canvas, because like the turn these pixels transparent operation seems to be very cheap. So like maybe putting a black or some sort of background texture behind the canvas is the cheaper way to do it. Right. But yeah, let's figure that out as it happens.
When you say the 2D canvas clear, which operation are you talking about? Is that something that we assume that the browser is doing every frame?
Specifically, the clear rect, we can give it a coordinate and a width and a height to be like blank this out to fully transparent. So it
Just
seems
has
it's a primitive for the 2D context at least.
Oh,
Yeah.
okay. Um, so what's the point of this function? Is it just a fill rect, but it has an implied color?
Yeah, I guess so. And if we wanted to like put a hole punch in a circle, well, that's a rect. So, yeah, that's a great
Because
question.
it seems like just the composition of calling
Fill rect with transparent.
fill style and draw fill rect, right?
Hmm.
Yeah.
Yeah.
I don't
Okay.
know. Maybe they just wanted to give you something that was convenient. It's totally
It's
fine.
it's weird, right? Yeah. So maybe we don't use it. Maybe we just paint over our entire thing every time. Because yeah,
Yeah.
we couldn't.
Yeah.
Even if we did, we would be taking the previous position of the ball or the bricks and writing them to black versus drawing everything black and redrawing everything. So okay. So then what we want to do is we want to dot fill style equals, let's go with a classic green. And then what was our position for this? So this was actually, we had a vertex shader that was
Yeah.
taking our uniform and adding it to the X and Y.
So the coordinate system that we're going to be dealing with in the canvas is actually quite different to the coordinate system that we had when we were using OpenGL. With OpenGL, the coordinate system was probably more like what you would think of if you're doing math, where the exact center of the canvas was the origin, right?
Right.
And then everything was kind of normalized to
Mm-hmm.
like essentially it's not the unit space because it was actually kind of 2 units wide and 2 units tall. Here the origin is the upper left hand corner.
Yeah,
Right?
as we can see, I drew
Yeah.
drew it in there, and that's what we got. So
Yeah.
yeah, I guess if we want to, if it's a traditional breakout, I would say our ball starts in the bottom middle.
Yeah.
And so maybe that's what our initial point is. So maybe up here at X and Y, we'll do canvas dot width over 2 and canvas dot height minus size. Canvas dot width plus size divided by 2 to get the center point horizontally between, yeah. And then let's make our size 20. And I'm just going to start rendering this out so we can get our X and Y and size.
Cool.
That's not what those values should be. Perhaps it's actually that I am in this space. I assume that the point I've set these constants, since it hasn't re-rendered the canvas width and height, might still in fact be 0.
Yeah.
So we should take those from a different source. All right. Well, that time I'm stumped.
Okay. So can I see the expression for X and Y one more time?
Absolutely.
Well, we are clamping it there. Yeah, it's that clamp stuff.
There you
go. Yeah.
And set these mins and maxes are, oh yeah, gosh. Let's just let that go for a second. Okay, that's where I expected that to show up.
Okay, yeah, great. Do you want to move it to the middle of the play field as well? You could.
Sure.
Cool. And I just realized one cool thing we can do now that we have a nice API for drawing primitive shapes. We can actually make this an actual circle if we wanted to. We can make it actually look like a ball.
We can make a ball. Yeah. Amazing.
Yeah.
Let's see. I was going to change this clamp real quick to be X is clamping from 0 to width, and Y is clamping from
exactly
0 to height.
Yeah, and the size subtraction may be relevant there, right? We might want to add the size to the 0 and subtract the size from the other extrema.
And really, it's probably like size over 2. We probably want half, right? Or no. No, because we're not working with the center point there.
Yep. Well, it depends. In the kind of like visual entity, what is the origin of that visual entity? It's the upper left corner, right?
Right. So 0. it
We
actually
would
is.
not actually be adding size to
To-
the lower bound, right? On either side.
That's correct. Yeah, because on the right and bottom bounds is where we want to. Yeah. Okay.
Yeah.
Cool. And then I guess let's see, the next thing to add to this is our impulse, but actually we already did that, didn't we? We have our left and right. But you know what it is? The speed is infinitesimally small for a pixel-based thing instead of a. Whoa! Ah, it's
So
beautiful.
we do need to blank the screen. It looks like. I think
Yeah.
your instincts were right.
Let's see, 0, 0. Perfect. Do we have to though? It's wonderful.
Yeah, well, we could be making Tron, right?
We can make Tron.
Yeah.
And interestingly, my impulses are now backwards.
Yeah, because we have a reversed x-axis. Oh, sorry, inverse y-axis, right?
Yep.
So the y speed needs to be. Yeah, exactly. Wait, so why is the x speed?
Nope, I don't think it needed to be.
Okay. Okay.
Yeah, that's perfect. My brain was extremely confused because half of my axes were backwards. And
Yeah.
it felt like all of them were backwards. Okay, cool.
Right.
Well, we're back to where we were last time with a lot less code.
Yes. So we have an interesting. When I saw the animate around, I can't tell if it's because this is just the latency through the screen share, but it looks a little choppy. Is it just because the velocity is really high?
The velocity is pretty high.
Okay.
Let's just see. Let me see if I can.
What?
I'm gonna turn down the resolution for you a little bit, so maybe it'll come through smoother.
Okay.
But yeah, so if I turn it to 5, it's much more reasonable. And
that looks pretty good. Yeah. I'm actually kind of curious what happens to if we have decimal positions, right? Which will certainly come into play at some point. So if you change the speed to like 5.1, what will happen?
We change the speed to 5.1. Oh, I think it should work.
Yeah,
just fine.
It should just be like rounding, right? Basically.
Well, it should make an attempt at like half pixel rendering too, which if we zoom all the way in here on this, we can. Oh boy. Yeah, I mean it's not always the sharpest edge, I think, and it seems like it's trying to do its best to apply it to a pixel-based setup.
Got it.
Yeah, I don't think we're locked to pixels in any way for this.
Yeah, well, what I'm saying is that like we definitely once we get into doing things like accelerations and that kind of thing, we're gonna have, or we're multiplying the velocity by, or the displacement by some delta time per frame. We're gonna have kind of like half pixels and that sort of thing, and then figure out exactly where that's actually rendering. I think I want to say that just straight rounding is fine in those cases, but as long as like internally the simulation is keeping track of partial pixels, I think we're in a decent place, right?
Yeah, I think we'll be good, and how it chooses to render it should be clean for us. So, so we've got this back to working with 2D. Do you want to think about bouncing and maybe the user paddle? Like maybe in fact we should turn this object into the paddle since we've already wired a keyboard to it.
Yeah, that sounds good.
And really, I'm just going to turn off the Y control.
Yep. And then we'll maybe want to just staple it a couple pixels off the bottom of the screen. I don't. Yeah. So the Y position is going to be the height minus the size.
Oh, yeah, height.
Minus a couple more, right?
Cool.
Yeah. And, that gap at the bottom, we can figure out exactly what will make us comfortable.
Yeah. And then if I was doing this, I would actually make, the Y. Oh, because I didn't want Y times 4, I wanted the second size times 4 to give us like a
first size times 4. Yeah.
Yep.
Width. Right.
A nice paddly object.
Yeah.
So that actually needs to do a little different clamping. So I think I'm actually gonna start tracking this separately, so we can do X size, Y size.
Yep.
That'll make everyone happier. Minus X size, Y size. So we don't really need to clamp the Y anymore. X size, Y size. Come on. Nope, I just wrote it backwards again.
No, that's cool. Great. And then its position needs to be, because we are on, like, I wonder, do we feel like it's easier to think of the logical position of the paddle as being the center of the paddle or the upper left corner? It doesn't really matter as long as we are consistent. The clamping looks beautiful.
The clamping's working. And yeah, the offset is clearly picking the top left corner instead of. I like thinking about the center of the paddle as the object center if possible.
Okay.
But that, for this context, maybe that's actually going to annoy us.
Well, what are the?
Oh, I see.
The things that we really need to know are.
It'd be something like this, right? To redraw it in the center. The clamping will be off now.
Yes. But that would be basically we're changing the rendering origin to be the center of, or at least the top edge center, right?
Yeah, everything does work pretty well except for our initial position. So maybe it is just tweaking the initial position and then letting the system take it from there.
Yeah. So maybe width. It's the screen width divided by 2 minus
the X size
half of yeah, exactly. So that looks pretty good, right? Yeah. It's always hard for me to know symmetrically what exactly.
It's... Yep. A little optical illusion, but that looks like it is in fact at the correct pixel.
Wonderful.
Okay, great. So we've got that. I'm gonna give it a little more gas in the tank.
Yeah. You know what feels really good about breakout paddles, if we get to it, is to give it a little bit of acceleration and deceleration, so that when you start sliding it and you let go of the button, it still will kind of like ease to a stop, almost like you're playing air hockey or something like that, right? Yeah, that'll be really nice because it has that very. It's like when you have that linear animation curve for CSS animation. It feels like stuck on what is the pure definition of motion right now and has no real physicality to it. Yeah, I am getting way ahead of us though. We can deal with that later, I think. Yeah.
But we might. So I'm gonna actually start breaking some stuff in the game loop up into like more logical chunks and clear the context at the top.
Yep.
Have the paddle drawing be its own section. And maybe think about drawing a ball now.
Right. And then if we're going to do that, why don't, on line 56, rather than calling it draw paddle, let's call it simulate paddle, because this is the logical piece, right?
Yep, totally agree. And it's easier to refactor later. That makes sense.
And then line 64 is when we actually draw the paddle, which may be reasonable to kind of just think of that as a separate thing as well.
Yep.
A lot of times the way that this kind of thing gets structured is that all the simulation will happen all at once, so all of your collision and input handling will be kind of like handled in one kind of portion of the game loop, and then we'll pass it on to rendering after that point.
Gotcha. Okay.
But you know what? I actually think the way that you had it before was fine, and it's actually easier to read when we've got all of our interactive entities kind of like splattered onto like one flat function as it is right now, right?
Yep.
Yeah. Okay, great.
Cool.
So for the ball, let's not do any collision detection first. Let's just make sure it bounces off the walls fine. And if it passes through the paddle, then that's okay.
What I was gonna say, let's maybe just start by drawing a circle.
Right. So this is a little bit more complicated, right? There's no just like fill circle. Correct. I think what we do is we call begin path, ctx.begin path.
Yep. And
ctx.ellipse with a shit ton of arguments there.
What is this sucker? Whoa, look at that. Cool. I was going to use arc, actually.
Arc. Okay, great.
Well, let's
No, let's do arc. If you have an inspiration, let's follow that.
I do, because arc is we can do 0, 0, radius of, we'll give it size just for now. Okay. And then I think start angle, end angle at 360 gives you a circle.
So arc, is it like a, it's basically like a pizza slice? Is that what this function is rendering? Is like a kind of wedge shape?
So we've since we've begun a path, it's basically what we've done is it's like one of those, it's like a compass, right? We've taken a compass and opened it up this much and then said draw this many degrees.
Oh, I see. And it's path. So right. How does it know how to close that path? Will it close it along the radii or
so we close and yes, the arc should be, I just drew a 360-degree arc and it closes, whatever path closing algorithm it does is probably fairly advanced, but you only need to draw like the 2 points of a triangle to fill in the final line. So I think it just takes like whatever order you gave the points and the first and last one and tries to draw the shortest path between them, which in this case should be like a 0.
Yeah, well, I would imagine that normally what happens if your path isn't closed and you want to fill it, it'll just draw a line between the beginning point and the end point, right? It'll just, yeah, okay.
And look, there's a circle.
Woo. Okay, it is white.
Which is what I claim to have told it to do.
Okay, great.
And so here's a delightful thing. I gave it 300 as the current coordinate. But when I did it 0, 0, we have this lovely semi quarter circle up here, because arcs are drawing from the center. It's drawing a path around.
Yes. Yeah, so it might start to get a little bit confusing when we talk about, because like I think a lot of our bouncing, we can, like, probably the easiest way for us to simulate collision is to, well, we'll probably end up treating the ball like a square, right? When we want to do collision detection, right? It's just a little bit easier on the geometry. Otherwise, we'll spend like literally 90 minutes trying to figure out how to do circle versus rectangle overlapping. Although it might not be that bad. It might not be that bad. But I think the point that you were getting at, though, is that like we're kind of using two different conventions right now for how we render things, right?
Yep.
The ball has an XY position of its center, whereas the paddle has an XY position of its upper left corner.
Yep, and for what it's worth, these appear to be the equivalent arcs and ellipses, so we were both on the money for that.
Okay, fantastic.
Yeah, so
I like arc.
I like arc too.
Fewer parameters, always good.
Yeah, I dislike having a couple extra duplicates and zeros in there to make a circle. So, yeah. In the future, if we do have it going fast, I like that with ellipse you can maybe elongate it, and it takes a rotational direction for like how to draw that ellipse. So I can kind of imagine the ball maybe getting a little stretched out at high speeds.
Yeah. Or another way that we could do that effect is to essentially draw the ball multiple times with like a contrail, basically.
Cool.
A highly hazardous to your health contrail.
Just like all contrails, obviously.
Yes. Yeah. They're degrading our mental capacity. The centering looks weird.
Yeah.
Was it just because you moved it?
I moved the paddle. I moved the paddle. That's the default, which I think is correct.
Okay.
Strange, but correct. The green thing looks a little off.
Yeah. The green thing looks a tiny bit off. Maybe we don't care. I don't know.
Let me try to just like stretch it out so it stops feeling that way.
Okay.
Yeah.
Yeah, it looks like it's slightly to the left, a smidgen, but I don't know why. But
my test, I use the screenshot tool to be like, that's 600, and if I get 300, I'm like smack in the middle of both objects. So it's our eyes.
It's our eyes, as usual. Okay, fantastic.
So yeah, so now we want to give this an impulse. and do our X and Y clamping on the ball, just bouncing around, and maybe ignore the collision with the paddle for now.
Right.
Cool. So let's see. I'm just gonna paddle speed so we don't lose that. And actually, I think I want. So let's see. So the ball is going to bounce around, and it's going to have a constant velocity. So we're not imparting acceleration onto it yet.
No.
Okay. Great.
I'm not actually sure if we'll ever have acceleration. We might be doing all impulses, and if we do acceleration, it might be a deceleration to make sure that we have. Like, I think steady state long term, we want the ball to basically maintain the same energy, which is to say, because the mass is constant, we just wanted to have, like, in the long run, the same velocity. But we might end up changing its velocity if we decide to do something like English, like
right, exactly.
English meaning the term of like adding spin to the ball when if you hit the paddle with some kind of velocity relative to the ball's velocity, right?
Exactly.
On the x-axis.
Yeah. Okay. So we have.
And that's kind of where all hell breaks loose. Basically, it's going to be really, really chaotic and confusing.
I'm so excited.
Yeah.
Okay. So we had. So let's see. We need. I'm going to give us a let ball x and let ball y equals. Start them off in this middle. X, y. And then we had we had ball x equals plus vx.
And the ball's relationship to y size is just accidental, right? On line 77 right now. That is the radius.
Totally correct. So let's do ball size equals.
Let's call it the radius. Yeah.
So even if this is moving, it's imperceptible because fractions of a pixel are. All right, goodbye. It was great seeing you, ball.
Yeah.
Cool. I forgot what our little check there was. So I'm gonna look at the game repo where I haven't deleted this code yet.
Yeah. Well, what we can do is we can do the same clamping that we were doing with.
Great point.
So line 68 we can copy twice, but we're going to have slightly different math for the ball, right?
Oh yes, because yeah. So let's see. So we're gonna do clamp that, and then the ball 0 is going to be 0 plus
the radius, plus the radius. Yeah,
plus the radius.
Plus the radius. Yeah.
And then it's going to be width minus the radius. I'm glad that's the radius. That makes that math
yes.
very nice. Cool.
It's like, oh god.
Goodbye. Wait, we'll get it back. Hey, minus radius.
Yeah.
And stop.
And then now we want to bounce it. So what we'll do is we'll also check the position along each axis.
That's right. Yeah.
Yeah.
And I'm gonna refresh my memory on what we did last week, but it was just a check on the max value, wasn't it?
Yeah.
We didn't even commit it. It doesn't matter. I made us delete that code before we shipped it.
Oh yeah, we deleted it. It's okay. So so what we can say is that if the ball's x value is equal to 0 or equal to it's equal to 0 plus the ball radius.
Yep.
And why don't we say less than or equal to, just out of paranoia? Is that okay?
Yeah, I agree with that.
Yeah.
Ball x. Yeah. Width minus ball radius.
Can I make a psychopathic code suggestion?
Absolutely.
This is a pure Jeff Leeism that you will get tired of on this stream over time.
I can't wait.
But the way that I like to do, oh nice. Now it's gonna just The way I like to do the mathematical expressions like the one you did on line 75 is actually to have the inequalities all point in the same direction. So I like putting width minus ball radius less than or equal to ball x. And that actually kind of like makes it look a little bit more like how you would write it on a piece of paper.
Yeah,
You
I
would
agree with
basically, yeah.
that. If we're gonna do that though, I'm gonna have to put my parentheses close to the or operator because otherwise it gives me the cringe. So
Yes, totally.
I'll accommodate that.
Yeah.
Height, line. You know what? I want these can both go a little faster because
Yeah.
let's get some bounce in here. All right, great.
Beautiful. Okay. So it deserves to be mentioned that the clamping that we do on line 73 and line 74 technically may cause the simulation to lose a little bit of energy if you're really into physics. Because what will happen is the ball might actually simulate frame after frame such that it's maybe we're actually like a little bit further along in the bounce away from the wall than what we are simulating here in code.
Yep.
Because we're essentially losing the amount of time where the ball kind of exceeded any of the boundaries. In that amount of time, it probably should have been like moving the other direction in that amount of time. But
right.
I have never really made a game where that really mattered that much. I suppose if you're doing something that was like very periodic and rhythmic, that would start to matter. But the name of the game in making video games, so to speak, is faking it. Like 100% just like fake it till you make it, right? And this looks pretty good for my money, I'm gonna say.
I agree. And it's yeah. I think this looks good. I think it feels good, and when I look at the ball, I don't have like the perception that it's slow or losing something at the edges, which is always nice because like I feel like we have to go by feel as much as we do by the math on this one.
Absolutely. And it would be good to keep the code simple as well. Okay, so do we want to try to make it bounce off the paddle now?
Absolutely.
Okay. All right.
So I guess yes, at some point in here, maybe what's our simple version is like we're not going to necessarily think about the edge of the paddle. We just want to say if it hits the paddle, it goes back up to start.
Yeah, I mean, we could make it bounce off both dimensions, I would say relatively simply. It's just a matter of implementing the x-axis as well, but why don't we just start with the y-axis?
Okay. So what would be your thought for that? So we're basically going to do a collision check.
Yeah.
Yeah.
Yeah. So there's actually a lot. This is actually a super surprisingly deep piece of surprisingly deep subject matter on doing collision, because we actually might be in we might get to a point where we need to know where the ball was before the frame. Maybe we can tell that from the velocity, but there are times when like maybe you've accidentally tunneled through a thing that you're trying to collide against, but if you're moving, you want to know like where it was before and where it is now, and kind of draw a line in between those things and see if you ran into anything over that line. But maybe to simplify, what the way the collision is going to work here is we could just say, this is the absolute simplest thing we could do in this program, is if the initial y velocity of the ball is positive, which means that it's moving downwards, and its x position is between the left and right bounds of the paddle, and its y position plus its radius is greater than or equal to the top edge of the paddle, then you have intersected the paddle.
Greater than or equal to the top edge. Wouldn't that cover everything from paddle up?
Greater than or equal to, because the y-axis increases as you go downwards. So it's actually from everything to the top edge downwards.
I'm already in the wrong coordinate system. Yeah, great.
Yeah. And we might even want to do this before we do the wall bouncing. It's always like a question, if you can collide against multiple things, how do you resolve those in order? But maybe we can do the wall as our final like cover your ass check, and then do the paddle bounce first.
Well, yeah, and there's always that interesting. There's like that there's that edge bounce over here where sometimes it might hit in the corner and go exactly the opposite, but I think the order we do it, it'll work out just fine.
Yeah. And the thing is, the reason why I'm suggesting that we do it, we do the paddle first is that we want to know what the velocity was. I mean, I guess technically you can't bounce off the paddle and bounce off of the bottom of the screen at the same time, or you shouldn't be able to. But it helps to just have like the velocity be the original value, and we update the velocity on the y-axis on line 83 right now, and I'd rather not take that into consideration. Yeah.
Yep. Wait, and ultimately we're gonna have something where like when we're gonna add the death box down here too. So like maybe the paddle collision is gonna be the same as the death collision on the bottom. But we'll just have a different different check for that. So the y-axis thing running last makes a lot of sense. It shouldn't ever get hit.
Yeah.
Okay, so paddle. I'm just gonna drop some values in for figuring out our paddle x values. It's probably time to change this to paddle x and paddle y. Somebody just claimed out x and y, but it doesn't get to learn out the whole time. Oops. So let's see. So we have paddle x, and this is actually the left edge of it, so that's okay. And then this is paddle x plus x size, and that should be the bounds of that at all times.
Yep.
And then so you just like is in paddle x is paddle x less than equal to ball x. Can you do this in JavaScript?
Python you can, JavaScript you cannot.
That's too bad.
Yeah.
Is that the Jeffley style? Is that do it?
It very much is. You may want to also modify by the radius as well. I think, yeah. And so here's the question about like what shape do we treat the ball as when it is moving around like this, right? And I actually think the simplest thing you could do is just treat it as if it's a square.
Yep.
So that there's basically invisible corners on the ball that you cannot see. They may end up look like I think the bigger the ball is relative to other artifacts, entities on the screen, that'll start maybe feeling kind of like garbage, especially when we're destroying blocks and that kind of thing. But I think as a starting point, that's actually not a bad way to handle the collision detection.
Okay. So that would be on the left, we subtract the ball radius to give it basically 15 more pixels on that side. And we add it on the right side. Yeah.
Correct.
Yep. Okay. Okay, great. So then if we're in that and let's just see. So this is ball y greater than or equal to, because the y is going down. Paddle y. And then it's ball y plus radius, right?
Yeah.
Yeah. So that's being very generous about where that's happening. So I'm gonna since I started putting things in variables, I'm gonna do that here too.
What happened to the simulation just now?
That's a great question. I'm hoping that it's that I left a trailing parentheses off my if statement and it just stopped counting some velocity checks.
Oh, I would have thought it would just be a parse error or something like that. But maybe it was correct. A script thing.
Is it this? What it did is it took ball x, and it's only going to do this if my collision check is correct. Oh.
This is very complicated. What you're doing here?
Well, it's running only this line as the one line of statement.
It's as if it's indented. Yes.
Shouldn't
Kudos
do that.
to languages that force you to have curly braces on your if statements, right?
Dude, tell me about it.
Yeah.
Okay. So great. So in this case, we want to negate the. So we want to negate only the y.
Correct.
Oh, just like that. Boom.
Yeah. So once again, the sort of pedantic point to make here is that the is in paddle y
Mm-hmm.
calculation there
Potentially
is
losing
kind
some.
of no, it's actually correct for maybe every situation that this game is calculating. But
Mm-hmm.
if it was possible for the ball, let's say the paddle was actually in the middle of the screen, then you may want to do something where you like the ball is never going to bounce off the bottom of the paddle, or at least we should just make it that way. What the hell just happened right there? That was interesting.
Oh, I think I saved the file. I saved the file.
Oh, okay. Yeah. Do you see it kind of like doing a weird thing coming into the side of the paddle?
Whoa! Yeah.
It's kind of like tracing along the side.
And it's great because every time we run the simulation, we just get that repeated.
Yeah. This is a very interesting little bug that we have here.
So I have a thought about this, which is that if we're doing this,
yeah. So I think I see what's going on.
Vy.
What's happening is
yeah.
Is that the ball is.
Well, it's in it multiple times, so we're actually we're rapidly negating it. But what we actually want is for this to always be negative if this check is true. So if in fact it enters the paddle and like has a couple frames of being inside of it, we really want it to be its velocity to be. We want to make sure that it continues away from it in all circumstances because that's what the paddle should do.
This is what I was getting at from before was that the extra check on line 83 that we should have is if the ball is moving down. So if we just have a
because that is the fix.
That is one way to do it for sure.
Yep.
The other thing I was gonna say is that line 83 could be we only reflect it if Vy is positive. Is the other way that we could do that.
Bingo.
Yeah. So do we need a side bounce and a bottom bounce? I guess there's like right now what we're seeing is, and it's kind of funny how like when the simulation starts we see it right away, where it kind of it overlaps to the side of the paddle. I'm not sure how badly we want to deal with that, but one way we could solve this is by making the paddle like really thin, right? Like that might be actually just like a clean way of solving this problem. Because otherwise, visually, to make us feel good, you'd almost want the ball to bounce off the side of the paddle, right? You'd almost want it to reflect on the x-axis as well.
Yeah, it's so interesting too that like only on this very initial one, because like if I do the collision, if I move the paddle myself, it does bounce off the top. So why is it hitting inside the paddle this time?
It's because it doesn't overlap on the x-axis until it's pretty far along on the y-axis, right? Does that make sense?
Yeah, is one thought on this too. We modify the position before doing this. Should we in fact do this check on the previous position before we do the adding the velocity and clamping? Like, should we check collision? Should we check collision before this, basically? I guess maybe should we check it both times?
Where the clamp goes is a bit of a philosophical question. I do think that the clamp should go later than any kind of ball-paddle interaction.
Okay.
And whether it goes before the world collision or after the world collision, it doesn't really matter. Like, the world collision is line 87 through 92, right? Yep. That's...
well, interestingly, it looks exactly the same, so...
Yeah. Yeah, so that initial frame is actually... It's really lucky that we kind of, like, chose an initial starting system where we get that visual artifact right in the beginning. And it's because the ball has traveled down far enough along the y-axis. And when I say down, I mean like a larger value on y, because the y-axis goes downwards. It's gone far enough downwards along the y-axis that it's already maybe below the top edge of the paddle, but that hasn't overlapped the paddle on the x-axis yet. That's what we're seeing here, is that it's like it notices pretty late that it's supposed to be bouncing, right?
Yeah, interesting. Is that
so
does
another
that mean
way
our,
that we yeah, so go ahead.
I was gonna say, does that mean our x-axis check is too restrictive? Let me change the vy. Oops, change this to 0. So I just want to see, like, you know, I think what I'm seeing is in fact that that's wrong. Yeah, check this out. Oops. Like, that check is what feels wrong to me, and I think that's what we're witnessing, is that it's not hitting.
That's interesting.
The edge of our paddle is off. Yeah.
It should be bouncing, right? Because like the simulation is treating the ball as a box. Correct.
So let's see. So paddle left X. We're drawing this all the way. Yep. And then it actually does the right. The right probably has the same property. Yeah. In fact, did we get this? So if I take the radius away from both of these, is it in fact better? It's better without the radius there. So I think maybe what happened is that in fact our radius constants were backwards.
Because
this is paddle left x is less than ball x minus ball radius. But that means I can get...
Should be plus ball radius?
I think it should be plus ball radius, yeah, because I can get almost a whole half of the ball on the paddle, whereas this time...
It should bounce.
I should be able to hug the very edge of it.
Yeah.
So I'm trying to hug it. Yeah.
Yeah, and that feels good, right? That feels reasonably good.
Yep.
If the radius of the ball was smaller relative to the size of the paddle, it would feel even better.
Yeah. And now when we go back to 6 and 3, now it's not intersecting as much because our...
Yeah.
Great.
So another way that we could have done this is, rather than just saying line 80, the expression could be more complicated, where line 80 could say, like, if the previous lower edge of the ball was above the top edge of the paddle, and the current edge of the ball is below the top edge of the paddle, then bounce, right? That's another way that we could have added some directionality to it, right?
Yep.
Because that would help you deal with situations that might actually be impossible in this game. Like, what if the position of the ball, like, started inside of the paddle for some reason? You know,
right. Yeah, absolutely.
Or if we had some extreme situation where the ball was traveling so quickly that it almost teleports from one position outside of the paddle above it to another position fully below the paddle below it, right? Like if there's some kind of teleportation thing that's going on.
Yeah, though I am glad we have this we have our negative check here, so I feel actually pretty good about that half. But yeah, I agree. Yeah, I do want to make the ball a little thin, or the paddle a little thinner too, which I think. Yeah. It's a good test of the simulation that in fact everything keeps on chugging when we do that. So
yeah.
But yeah, I'm trying to think of like the teleportation thing still, and that does make sense, especially if things end up moving really fast or we have a velocity. Yeah. I imagine at some point we might have a strange situation where if the ball can ever get faster and starts like really clipping fast, then like it could be above the paddle and then below the paddle, and hit the death box instead of actually being like us taking the vector of collision, which is what you're saying, and I'm just catching up slowly. So yes.
Yeah, this has to do with like, is your frame rate of simulation, is the resolution of that good enough to handle whatever faux physics you're implementing in the game? And I think for Breakout, like, largely what we have here is just fine, right? I think it'll be okay. We're not trying to do a perfect energy conserving physical simulation of an environment, right? We're not.
Right.
This isn't like a supercomputer simulation where we're trying to figure out what happens after you do this a million times in a row or anything like that. So I think we're good for now. It may be cool just for physical effect to kind of be able to hit the ball on the side of the paddle, even though that'll just cause it to bounce off and into the death box anyways. But like it may look cool to do that. Like right there, it might have been cool for it to bounce in the other direction a little bit before.
Yeah. Well, and especially when I think of that side bounce, I think more of the English too, where I want to be able to I want to be able to move it with this and not necessarily like ever have it hit the side and go down, but if I get the left to right motion with the ball to impart that spin. So I'd like doing. I think English will be a really fun addition, and it'll feel right.
Yeah. So English, I may recommend that we at least do it later.
Not today.
Rather than sooner. Although honestly, English is what's going to give this simulation any kind of interesting motion whatsoever. Because if you don't have English, you have to have some way of changing the angle that the ball is bouncing. And right now, because all of our changes in velocity are just reflections along one axis or the other, we're basically just getting two different angles off of any given bounce, right? There's no variation there whatsoever. And if the X and Y velocities were identical, we'd actually have only one angle. It'd be fully 45-degree bounces like everywhere, which is not necessarily all that interesting. So in this particular, so this is possibly the most vanilla. I mean, the worst possible thing would be have only motion on one axis, right? If we had it like moving directly downwards. So like the way that we could introduce different angles, there's maybe 3 different ways that I can think of. One is that if we introduce blocks and we say that like if you bounce off of different positions on the block, it'll actually change the angle of reflection. That might do it. You could say the same thing for the paddle. There are ways that I've seen of implementing this where it almost treats the paddle as if it was curved, so that like if the ball bounces off the outside of the paddle, then you get like different angles of reflection. I don't know how much I love that though. And then the other way is to like somehow account for the motion of the paddle when we calculate the reflection. And I don't know exactly, like theoretically, if you had no spin on a ball, I don't think the relative velocities of the paddle and the ball matter for the bouncing. I think physically speaking, the only thing that we care about in terms of the bounce is the y-axis motion, right? The motion along that one dimension. But relative velocity of the ball and the paddle comes into play if you imagine that like there's some kind of friction between the ball and the paddle, and it's like basically either imparting some of the velocity, the difference in velocity onto the ball itself, and literally pushing it in one direction or the other on the x-axis, or that there is that same friction, I should say, or there's that same friction plus the paddle is actually causing the ball to rotate. And then there's like kind of like air turbulence or whatever, and it's actually giving it some degree of spin or curve. Again, so it's actually a pretty complicated subject to kind of model. We might want to do a little bit of research to see at least what are some promising initial directions for us to kind of look down. But why don't we add some blocks? Do we want to do blocks?
Let's do it. Yeah.
Okay.
Blocks are... Now let's do blocks. Let's kill blocks. We know what that's going to be. That's just a rectangle. That's just failing.
Yeah. Oh, you were talking about like, do we want to kill the ball as well? We could kill the ball too.
Let's do it. I'd rather throw some things in there and get a more interesting bounce going around and see how it feels. So,
I agree.
Okay, so simulate blocks, and actually probably we probably have a interesting thing where we let's see. We'll need maybe like an array of blocks, and basically we're going to model these similar to the paddle, right? Like we're going to have a kind of, I don't know, blocks are all the same size, and then we have an array of like positions and draw them out there.
Yeah. Do you want to make a make block function or something like that?
That's what I was thinking. Yeah. Once we got some constants and some positions, we'd have like make block that pops on the screen, and then maybe the collision check is iterating over the array of positions and doing a like check block intersection with the ball position.
Yes.
Cool. All right. So let's see. block X equal 100, like block Y equal 30. And
This
then
is the block width and height?
Yeah, you know
You
what?
want to call it block W or block H?
I
like
do.
Okay.
I do indeed. I was like, that is strange.
Yeah.
So let's do 0, 0, 80, 0, 160, 0.
Yeah.
So that should be 3 blocks like right up here.
Uh-huh.
And then constant block equals xy. And then we'll do context dot fill style equals blocks can be red.
Okay.
And context dot stroke style equals yellow. We'll get a little something on there. Dot draw. Oops.
Fill rect.
Yeah. So let's see. This is going to be x and y and block W, block H.
Can we call this function draw block?
Yep.
Or render block? Yeah.
I like render. Render feels like we're still using 3D context.
Yeah. It also makes it sound like we're super legit, right?
Draw blocks. And actually, this probably happens at the end because we might delete one the second the paddle hits it.
Correct.
Blocks dot for each render block 0 B1. Hey.
Nice.
And I threw a stroke in there because I wanted to do ctx dot stroke rect xy block H block W.
It's the other way around, or do they block W first? Yeah.
I like mine, but you're correct. But now we have some distinctions until we want to like deal with spacing.
Yes, very cool.
Looks like blocks. I'm gonna maybe fill in some of this top row.
Yeah.
40.
This may actually be not a terrible time to use a for loop to populate the blocks, just because you won't have to do any of your mental math in your head. And,
yep. Checks out.
Yep.
In fact, I'm gonna do while. Can you do while let equals let x pause equals 0. Man, I've never written a while loop in JavaScript. Turns out.
Are you doing a for loop or a while loop?
I want to do while the x pause is. I want to increment until we got to like the field of play end. I can do a for loop.
No. I see what you're getting at. Let's just do what you're talking about, but I don't think you can declare the variable inside the.
No, I think that's
the conditional.
That's probably some beautiful Pythonism that I just wish was here.
Yeah.
Well, x pause
plus
is less
block
than
W. Yeah.
Plus block W less than width.
Yes.
Blocks, x pause.
It's gonna be dot push. Unfortunately, we don't have the shovel operator in JavaScript.
We don't have the shovel operator in JavaScript?
I don't think so. Yeah.
Yeah, you're right. That's what I get for writing Ruby for the last 2 weeks.
Yeah. We could be doing this in Ruby. There might be like a transpiler from Ruby to.
Uh-oh. I made an infinite loop.
Oh yeah. It's okay.
It's okay. It's okay until it kills my CPU for the stream. So let's see. What did I do wrong? This.
We are not modifying the X position, so it's
not
just
modifying.
Yeah.
Beautiful.
And yeah, we could even do multiple rows, and that's where for loops are nice, right?
Yep. That's what I say for.
Yeah. You mean to do plus plus I plus plus?
I meant to put a variable there. That's for sure.
Okay.
Good.
And then the width needs to increase between each iteration. Plus I times block height. Yes.
Okay, wait. Am I tripping? This should run 3 times. Oh. Oh no! I should increment. You know what? I'm just gonna do a little good old. Good old. Are you gonna print 3 numbers for me? You are. So is my render wrong? X and Y are here. We could log out these blocks.
Where are we drawing these things? There's a for each loop downstairs.
Yep. There's a for each that's rendering
0,
that.
V1. Okay, that looks correct.
Yeah. It only did put 7 blocks in the array, so this for loop is actually.
Xpos needs to get reset to 0 after every loop. So at the bottom, yeah. In fact, we could put let xpos equal 0 right here, right, in line 59. Get rid of it on line 56.
Yep, totally.
Look at that.
Very cool. I see some blocks. Now we gotta detect some collisions.
Yep. All right, so we are going to have... So I'm trying to decide right now, what's going to end up happening when we start doing collisions? Let's just do the collisions first. Let's not worry about destroying the blocks. I don't want to get too far ahead of myself.
Okay, you want to just bounce it off every block?
Yeah, and in fact, can we actually...
You want to do like a collide function? It's like we give it an object and the ball collides with it.
Yeah, we can definitely do that. I'm trying to think here, because I would love to be able to simulate x-axis collision too, because that's sort of what we would want to do here, but maybe we just start with the y-axis and go from there.
You mean like especially on this side over here, where we could easily get that little like bouncy. Yeah.
Yeah, exactly.
Let's do that. Let's just start a new function that is const rect collider rect collision equals you know, we're doing types here. We can actually define some types, or we can just do x, y, the type.
Yeah, well, I don't mind having types. I don't. There's nothing wrong with prematurely typing. I would say, it's a pretty low overhead way of ensuring that your code is correct.
You know what? I do love using TypeScript. So interface rect equals x number, y number. Oops,
W number, H number.
Yep. I was just wondering why I was angry, and you just don't need equals for interfaces.
And do we need? It doesn't need commas either. That's amazing.
Nope, not for an interface. It's not JavaScript. It gets written out. And then rect collision rect. I like it. I'm happy about that.
Okay, and we're simulating just against the ball, right? Is that correct? So we don't need to pass. We're not going to do a generic here.
I think so, right? Because we're gonna say the paddle is a rect collider and the bricks are a rect collider, and probably whatever's going on down here is the same rect collider for the death box. That's just 1 pixel high at the bottom.
Yeah, although probably with the death box, we could also just say that the y position of the ball is, you know,
if it ever gets that low.
If it ever gets less than something, it's just it's just it. Yeah.
Cool.
Okay, fantastic. So the technical name of a rect like this, when we deal with it in collision world, is an AABB, which stands for Axis Aligned Bounding Box. And the reason why the Axis Aligned Bounding Box is nice to work with is that you can, if you're dealing with 2 such objects, you can implement the collision logic by just doing span checks on the y-axis and the x-axis independently. That's why axis alignment's really, really nice, right? So all we do is we just check for overlap on the x-axis, we check for overlap on the y-axis, and we're done, right?
Delightful. Okay, yeah.
So it actually helps to have an overlap function that essentially just takes in 2 spans, right? So you have an overlap function that says you have span A and span B, and each span is 2 numbers.
Right. Is it like start and end, or is it really just like P0 and P1? Yeah,
it's P0, P1, like extrema. It's min max, min 1, max 1, min 2, max 2 kind of thing.
Okay.
And Yeah, you're being very disciplined by creating an interface for that.
We already started.
Sometimes you could just write a function that takes 4 numbers and just assume that you're ordering them correctly.
No.
Either or, it's totally fine.
Don't. That's why we're using TypeScript. I don't want to do that.
Yeah. Okay.
Great.
So,
okay. So really. Oh, sorry. What were you gonna say?
No. I'm trying to remember what the overlap math is. It gets surprisingly tricky. This operation. What is your guess, by the way?
Oh, my guess is that this is totally an interview question for a programming job that I've done before. Why can't I remember it?
If all of our numbers are positive, well, here's the problem:
Yep.
is that you don't know if the first span is. Can I share screen really quickly and I can do like a little diagram?
Yeah, you got your iPad drawing?
I do have iPad drawing. Yeah, can I just take over? Is that possible? Start sharing. Is this going to show up on the
I think the stream is taking my full screen, so it should be there.
Do you see it on Twitch right now?
Yeah, I do.
You do? Okay. That's fantastic.
Works for me.
Okay. There we go. Is there a way I can hide this thing? Probably not.
No, that'd be nice.
Yeah. Okay. So we can have 2 spans, right? We have this span and this span, right? And this is like the P0 and P1 of this one. And this is the P0 and the P1 of this one. And, we could be doing it vertically as well, right? The vertical equivalent of this is like this.
Isn't this just, we take the min of both P0s and the max of both P1s to get the full set? No.
Potentially. Yeah. So there's a number of different cases that we have to account for. We have to account for this case. We have to account for this case where it's kind of the opposite, where we have P0 here and P1 here, and then P0 here and P1 here. And then we have basically the disjoint versions of both of these, right? So we have this one and this one. And then finally, and it helps for me to label these, right? This is A, this is B, this is A, this is B.
I think the 5th and maybe 6th cases are one is fully contained inside the other one.
Oh yes, that's totally correct. Yeah. Now, I think there's a way that we can handle this using subtraction.
God, why do I think this is set similarity for some reason? I think it's this very similar algorithm.
If I knew what set similarity was, I would be so agreeing with you.
No, remember the interview question we gave at Shane? The set similarity question there where it was like how to match differing ranges. There was a very clever solution that was just you take the min and max and just like go to town. But this is not that.
So I seem to remember some subtraction thing where what happens if we subtract the P1s and we subtract the P0s?
We can always safely assume that P1 is the higher number, right? It's a certain end of a range. So
yes, exactly. So P1 and P0 relative to each other are always ordered correctly. The problem is you don't know if A and B are ordered in a certain.
Right. So so if we take the delta P1 minus P0 of A, and then do you apply that to the range in B somehow? Like we're getting the length of the segment essentially. We're saying how long is this?
Yeah. I actually do you know what advent of code is? It's like this kind of like so I did that in December, and there was exactly this thing, and I ended up writing out like a really long Boolean expression that kind of captured all of these cases, and then I kind of worked it out on paper, and I was like, oh, this is actually like one formula. It actually reduces down. So let's try and figure it out. This is our challenge for the next 10 minutes. I think we got it. We're programmers.
Yeah. I'm taking my iPad out and doing the same thing.
Yeah. So if we did. This is actually a little bit confusing, my notation here. what if I called this like A0 and A1 and B0 and B1? Maybe that's a little bit easier to read. And we know that A1's value is bigger than A0 and B1's value is bigger than B0. That's just the guarantee there.
Yep.
So if we subtracted B1 minus A0, you would get this length, right? And then if we just by symmetry subtracted A1 and B0, we would get this length. And they would both be positive, right? It would be positive here and positive here. And if it was reversed in situation 2, those spans would be negative, right?
B1 minus A0. No, it's still positive, right?
You're right. It would be still positive. So that's a hint, right?
Yeah, I think for the disjoint case, A1 minus B0 could be negative. That's the problem. And in fact, perhaps that's why, because it's disjoint.
Yes.
Is that always the answer?
What about the overlap situation?
A1 minus B0 and B1 minus A0 are positive for both of those.
Is that the answer? That we just subtract? So basically, both
I'm
of these.
I'm willing to try that. Yeah.
0?
Yeah.
And then if it's greater than or equal, that's we have to follow convention if they're just barely touching. If they're barely touching, then they're not overlapping, right?
Greater than or equal to 0, I agree with, because that's the edge of the collision. Yeah.
Okay, so the inequality ends up being this, which this doesn't seem correct, right? This seems if B is greater than A0.
We still have to do the subtraction, I think.
Actually, this makes sense, right? You want the right edge of your thing to be greater than the left edge of the other thing.
Right edge to be greater than.
And then you want the left edge of the other one to be greater than the right edge of, or you always going to want like this side to. Sorry.
Undo.
You're going to want like this side, A1, has to be greater than B0, or else you don't have an overlap in any case, right? Let me try and redraw all of these so I just use the right nomenclature.
Okay. I think it makes sense though. I think you're right. I'm digging it.
So I'm going to try to like just. So what was the other thing? The other thing looks like this, where you have B0 and B1 and A0 and A1. So A1, this has to be greater than this, because if they weren't, then this would be slid over this way, right? And it would be disjoint, right? And then this needs to be bigger than this, because if it wasn't, then relatively speaking, they would be like disjoint this way, right?
Yep.
So I think this is correct, right?
There we go. That's a nice little example. Yeah.
Well, why don't we let's. What are the cases? How can we disprove this to ourselves? Sorry, I'm gonna get rid of. Oh, there's not a very good way to like erase large areas here, so I'm gonna. Let's do the overlap case. A0, A1, B0, B1. Then A0, A1, and then B0, B1. Yeah, so let's go through our checks. Is A1 greater than B0? Yes.
Yep.
Is B1 greater than A0? Yes. Is A1 greater than B0? Yes. Is B1 greater than A0? Yes. Okay, so this is starting to feel correct, right?
I like this a lot, yeah.
Okay, cool. So the max of one thing has to be greater than the min of the other, right?
Yeah, and both have to be true, right?
Yeah. All right, I am going to stop sharing screen, so I'm giving it back to you.
Cool. My screen share is back on. You got me?
Okay. Yep, I'm seeing
Cool.
it.
All right, so let's do, based on this nomenclature, I'm going to go with span A and span B.
Or you can just call them A and B. That might be the easiest.
I can just call them A and B.
Yeah.
So let's see. So we have, it was A dot point 1 is greater than B dot point 0, and B dot point 1 was greater than A dot point 0.
Yeah.
And that's our overlap.
Does TypeScript have tuples? Does it have such a thing?
Yeah, it
do
does.
Do we need the span class, or we just make it a tuple of 2 values? Is that?
Oh. I don't know how to write that TypeScript tuple. You can do tuples as returns. I've never tried to do it as a parameter.
I think they're just arrays. Is it just bracket number comma number unbracket, something like that? Yeah. I almost like that better than having to name the components, just because it's such a simple data structure, right?
Yep. So is that, and this is number.
Yeah, a little bit of stutter in the declaration, but it's okay.
That's fine.
Yeah.
I can't believe that compiles. Delightful. Cool. Okay, so then our rect collision, and we're doing, this is like a collider with the ball.
Yeah.
Only.
So, yeah.
Yeah, what were you saying?
Nothing. I was going to say, one way to do this is you could say, we have... And how much information do we need to know about the collision? Do we need to know like what direction it happens, or is it? It's probably just what we want to know that it happened at all. Well, we do want to know what axis it's happening along, right? Because you could collide with a block on the side. You could collide with the block purely along the x-axis, purely on the y-axis, or some mix in between those, right?
Mm-hmm.
Like if you bounced off a block in the very corner of it, you might want it to bounce both on the x and y axis. Does that make sense?
Yes. So in our overlap, we're going to do overlaps on the 2 spans. We're going to do an overlap on the ball x span and the brick x span.
Yeah.
And then the ball y span. And basically, we're going to choose to say we can return a tuple from the rect collision that says x yes, y yes to be like
it's a little
tricky with both.
Because
oh, you just got really broken up. Hang on. Am I sending out too many bytes? No, I'm sending out a pretty normal amount of bytes. Okay, sorry, say that again.
Low is fine. Yeah.
Yeah.
It's a little trickier than that because for us to have a collision at all, you have to overlap on both axes, right?
Jeff, you're a robot. This is really weird. One more time.
Hello? Can you hear me?
Yep, I can hear you now.
Okay. So what I was saying is that in order for there to be collision at all, you need to intersect on both axes, right? And so you're going to be intersecting on both axes, but that doesn't really tell you. What you want to know is like, if I was already intersecting on one axis in the previous position, which intersections are new? Is it the x-axis intersection, the y-axis intersection, or both? And whatever axis okay, so first of all, for us to have a collision whatsoever, there needs to be an overlap on both axes. However, let's also check the frame position before this. And if we were already overlapping on one axis, I'm trying to prove to myself whether or not what I'm saying is totally ludicrous.
Yeah.
and I have my doubts. But I think this is actually a worthwhile start, though. Somehow taking into account the previous position of the moving thing, or really the previous position of both things, if both things were moving at the same time, is going to matter here. It is coming back to me that the collision resolution function that we're writing right now was by far the most complicated piece of code. in the gameplay logic of a lot of the games that I worked on.
Yeah, that makes sense. I believe
yeah.
that.
Yeah.
But that's okay. That's okay. I mean, I think we should start this. I think we should at least do the simple version. But yeah, how do we? So we're only going to be reversing the y-axis at this time, and you're saying that like our x, when it should maybe do an x thing, we're going to be a little wrong.
Yes.
Okay.
Yeah. So I think the simplest thing we can do right now is to just check an overlap along both axes,
Mm-hmm.
and if it happens, reverse the y velocity. Right. That's probably the easiest thing that we can do at this point.
Okay.
So let's not take time into account. Let's just say rect collision. This function returns a bool in this reduced sense, right? Like, are they just overlapping at all in this frame?
Correct.
Yeah.
Okay, so this is going to be overlap, and then we have rect dot. So let's see, our span one is rect x to
rect
x plus rect w.
Yep. Yeah.
And then ball rect dot x to ball rect dot x plus ball rect.
Yep. And this is where eventually we'll probably factor this out into a class, right? And just like call a method that gives us the span on the x-axis or y-axis, something like that. Yeah.
And then just do take this and do y's. And this is height instead of width.
Yeah.
Cool. Does that actually work? I think I need to have something on the return line. Otherwise, it just returns. Yeah.
Yeah, and then we need to actually check rect collision between all of the blocks, right? So.
Right. Which we can build. It's easy to build our block recs. Yeah, that's why we made the rect script.
Yep.
Cool. So then this is, we've got these two functions. I'm gonna pull them out of the simulation though because they're just helpers.
Yep.
With render block. Okay, so we've got our. So maybe the first thing to do is to take our paddle and turn it into a rect collider.
Yeah.
Because that'll be our good test of, is this thing working? So if rect collision, this may be const paddle rect equals.
Yep.
X is paddle x, y is paddle y, width is paddle. Oops. Yeah. What's that called?
I think X size and Y size.
Oof. Oof. Size and height is y side. Okay. Cool.
Would it be a fun thing to stream, like our refactoring process? Like, would that be
potentially?
Yeah.
I'm very tempted to at this point.
That is actually kind of like, for me, programmer ASMR a little bit. Like, it's just like watching somebody sort of like scratch the itch a little bit.
Oh,
so did that work?
Wait, good question. Yes.
Great. It appears to.
Well, that's slick.
We might get something weird.
There's no. I was gonna say there's no check in here for the paddle that it has to go up.
Well, technically, if you move the paddle, like, let's try moving the paddle to the center of the screen and have the ball bounce off the bottom of the paddle. Would that work? Can we do that?
Yes. That's.
And I just want to see what happens.
Okay. Yeah.
Let's do minus 200 or something like that. Okay, that's cool too.
Yeah, I'm just gonna try to play some reverse breakout.
Yeah.
It's working. It's bouncing all over the place.
Okay, very cool. All right, this is nice. We're starting. Oh, see, that was cool. It kind of bounced off the bottom of. It's kind of did this like, kind of bouncing in that little channel down there.
Right. So, man, we picked a really good set of starting coordinates because I think for the paddle itself, the paddle itself needs to always set the impulse to up. Oh, I see. It's because actually it's bouncing under the paddle now for some reason.
I actually think that's cool that it bounces under the paddle. I mean, it's not what our simulation needs, though, right? Like, technically.
Yeah, you're right though.
Yeah.
I like that as modeled, so let's do it.
Okay, yeah. This is becoming like a little bit more of like a real physics simulation here, right?
Yeah, totally.
And you know, if you wanted to be really fancy, you could make rect collision more generic and just pass in the ball's rectangle as well, if you wanted to do that.
That's what I was thinking that's possible, but I like that it at least closes over the ball at the moment.
Okay, that's fine.
Yeah.
So can we call that ball collision then? Is that a better way of naming the function? Okay, great.
And then let's do, so the next one is going to be bricks, yeah, dot for each.
Blocks is what we called it.
But
bricks is better. I think brick is better. They look like bricks. They're red and they have like a very nicely simulated kind of like grout or mortar in between them.
That's the spirit.
Yes.
Thank you, Visual Studio Code, for making that a very easy refactor.
Yeah.
Okay,
I
so
begrudgingly I'm starting to like VS even more.
I like VS Code a lot. Yeah. So if ball collision and then const rect equals x is b0, y is b1. That's not how to write that. And then width is brick. Oh, I missed him. I missed some. Brick. WH is brick H. Brick H. And then if ball collision brick rect, let's just do the thing. Okay.
Holy smokes.
Oh!
I'm not sure what happened there.
These physics are off the hook.
It kind of bounced a couple of times when it reached the corner.
I should be able to simulate that again because every hit should be repeatable.
So this is where knowing what the previous position of... Because what's happening is it's inside the brick.
Yep.
And because there's an overlap, it's constantly reversing its Y position, right? And so...
I have a thought on that, though, which is delete the brick.
Yeah.
But sorry, you were going to say something about time travel.
Not time travel per se, but like what we want to know is like if you were overlapping with the brick previous frame, we shouldn't simulate it. It shouldn't count as a collision, basically. Is the idea.
Yep.
I think so. I think if ball collision, that function was to be complete, we'd want to pass in the previous position of whatever's either previous position. It knows of the previous position of the ball. Maybe that's what we want to know.
So keeping track of that, that seems like the easiest kind of global state to manage as well.
Yeah, and then it gets complicated though. I don't know how robust we want to make it for the paddle climbing the ball, but like if this was like totally generic, you'd probably want to know the previous position of the paddle as well, right? So it feels like a fully mature collision function, if we were to abstract it this way, would be something like a thing that took in an entity, its previous position, another entity and its previous position, and it would return some kind of, oh my gosh.
Yeah.
Wait, you can do delete I in JavaScript?
Yes.
And then what happens to, it's just a gappy array at that point? Is that?
I mean, it's not doing the right thing, so search me.
I mean, this is doing the right thing. We're just not bouncing on the x-axis, right?
Yeah, that's fair. What? We're not bouncing on the y-axis there either.
Yeah, what the fuck? Well, I think maybe what's happening is... Yeah, that's weird.
A little bit.
I mean, it's kind of mesmerizing, but it's weird. Well, what does it mean for us to iterate over bricks and delete out of it at the same time?
That's what I was wondering. I think I might have goofed on that.
Yeah.
Yeah, I think in fact I want to keep a array of indexes to delete and then do that. Well, like,
Yeah.
'cause I don't like mutating my arrays in flight.
Yeah. I mean, the other thing you could do with a brick is have a flag on the brick that says that it is active or not.
Oh,
That's another
yeah.
way to do it. Yeah.
Now you're talking.
Yeah. I mean, I actually think what you were going for was also pretty cool too. You have a graveyard, elephant graveyard for bricks.
But I was actually going to just modify this array. I do like the idea of turning bricks into a better object later, but
yeah.
Future.
Yeah, if we had like an entity class, we probably have an array of collidables with ball kind of thing. And that would include the paddle, right? Like at a certain point, if we had a powerful enough collision handling function, we would just treat the paddle and the brick as like the same thing logically, right?
Yep.
So that still doesn't quite do what we want, and I think it's because we're not accounting for the previous position of the brick.
Okay. Of the ball, yeah. Okay. Great.
So one thing we could do is wherever we're simulating the ball's motion.
So this is where we add the velocity. So really, we could have like prev ball x equals ball x.
Wait, where do we add the velocity of the ball?
Right here on 141, 142.
Oh, okay, yeah. This. Okay.
Easy.
Oh.
Yeah.
So I get it now. Okay, so we're colliding before we resolve the motion of the ball. I think what we want to do is do motion of the ball first.
Okay.
Then do collisions. Yeah. And then actually, let's do the clamping at the very end. I like the idea of the clamping as being like cover your ass, don't render something weird kind of thing.
Gotcha. Yep.
Yeah.
Okay, then really the first thing our game loop does is just like ball x equals ball x plus bx.
Yeah.
Because like we're starting off with the impulse and going from there.
Yes, and then we can actually do. Maybe we could move this to line 115 because this is like if we want to like kind of like organize things. What we're really doing is we're simulating the ball, right? Or like, and so we can do the ball's position, like handling of ball physics, all in one place. So we do ball x plus equals vx down where we're simulating the ball. Yeah, totally.
Still does the same thing. Strangely, I got it to eat through a couple bricks at a time.
Yeah, it still does the same thing because we haven't changed our logic at all. I think, although we have changed it slightly, right? Before we were calculating collisions on the ball's previous position, and so probably what was happening is it was getting deep into the brick. And we were bouncing it based on where it previously was rather than where it currently is.
It's interesting to me that I've seen like it's that second bounce that it takes that really interests me though. Like this goes through, that one's fine, but why is it jumping through? Is
it hitting two bricks at the same time?
It's hitting two bricks at the same time.
Yes, it's hitting two bricks at the same time. Okay.
So okay, wait. There's a really easy solution to that, which is that we want to, instead of detecting every ball collision,
we just want to set a flag.
We want it
outside of the loop. Yeah.
Exactly. Yeah.
And then line 135 happens outside of that. Yeah. Exactly.
Yep. Okay, I think that's actually... It's interesting that our stuff can hit 2 bricks at once, but you know what? That's
It
fine.
totally can because there's a width to the.
Yeah, yeah. We're saying that the
That
ball
makes a lot of
is
sense.
a little chunky. It
Yeah,
really likes to hit 2 at a time on that side, and that's fine.
yeah.
Okay. And you know what? I kind of agree with that. What it just did.
Well, it didn't do any x-axis bouncing, which is a little bit unfortunate, right?
It should have bounced that. You're right. You're right.
Yeah.
But I do love the breakout thing where you can kind of get the physics to get it stuck in that quick bounce.
Yeah, you
So
get it into sort of like a concave space, right? It really
yeah.
kind of clears out the game for you.
So I think
And
if we have
then
x-axis working, it'll feel good.
the worst part of Breakout is like when you have one brick left
Yep.
and you have to English your way into hitting that brick, and it's just impossible, right?
Hmm.
In fact, it might literally be impossible unless you add some kind of English mechanic, right? Because like if it's always bouncing the same way, I don't know.
I was wondering that because right now we're getting a very repeatable game of breakout, which is interesting.
Mm-hmm.
Um,
Deterministic,
there you go. Yeah.
as it should be.
When it's like, in fact, the only move I can make is to exhaust the simulation, and I'm not really playing the game beyond making sure that it does hit the bottom.
Yes,
So that's
because
interesting.
either you die or you keep going, and the bounces are exactly the same, right?
Yeah. 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 Yeah.
Yeah, and like, how long are you going to be doing this right now? It's going to.
You know what? For the first round of this game, I'm gonna win it.
Are you having a good time though? At least, I
I'm
mean,
having great.
that's really the only outcome we're going for, right? Is to
Yeah.
delight and surprise.
I'm gonna call this a fun game loop. Uh,
Yeah,
it's amazing the stream only took 2 episodes, but yeah, it's a good run. I'm glad we did this.
yeah.
So yeah,
Oh man.
no. This is the DVD logo hitting the corner situation. It's gonna take a while.
Yeah. Yeah, I think probably because this is all floating point, like eventually it will converge on hitting that thing because we'll just like get enough error. There you go.
The only change I can make to the game right now is to not hit it.
Yeah.
Hilarious. Cool. Great.
That is fantastic. Um, we have about 15 minutes left in the stream.
Mhm.
Do we want to maybe try to do the x-axis bounce here? Do we want to fix the weird colliding inside of things because we're not taking account the previous position of the ball sort of thing? Or
I don't think we're colliding inside things anymore. We had the 2 collisions at once, hitting, like, we were double negating our Y impulse, so we kept going up.
okay.
I don't think we were ever hitting inside things in a way that like was driving us crazy. We are hitting on like our ball is apparently huge and just hits things right on the middle line every time.
Yeah. The ball is massive. Well,
Yeah.
another thing we could do is make the ball the AABB for the ball, the collision bounding box for the ball, smaller than the visual representation of it. Like you could make
Right.
it, whatever chord fits
Mhm.
inside of the little whatever sort of square that's exactly bounded by the circle. Like we could make that
Ah,
the bounding
right. So
box as well.
not a big square, but the square contained
Yeah.
in the circle at the that makes sense. That's
Or we can figure
probably
out how to do circle to AABB collision.
in our overlap function. We just wrote it.
Yeah, we did. We totally did.
I'd be down to figure out what an X collision would look like because it would be really nice to get some other kind of bounce going on here.
So, yes.
And like, yeah, should any of these have changed the X direction? Maybe is the question.
They should. So I'm gonna draw something.
Yeah. Share your screen back.
Okay. Yeah.
This kind of makes me want English, to be honest, as the next thing too. I want to have more control over this.
Okay. The English once again strike.
Yeah.
What's a good color for the? I'm trying dark mode this time. I think it's a little bit easier to read than light mode. What's a good color here? Do I want to do orange? Maybe is that too garish?
Your screen is still catching up. Hang on.
Okay.
What are you? Oh, there we go. Oh, it just wasn't on the front.
Yep. This is orange. I had blue last time. Is this a little bit easier to read, perhaps?
Yeah, that's nice.
And maybe I can get rid of the dots.
What
I
app
feel
is
like maybe
this?
it wasn't. This is Notability.
That's right. I asked that last time too.
Yeah. Okay, so we have a brick, and our ball is essentially a square, right?
Mhm.
And it's moving towards this. And with this diagram, we would want it to bounce on the y-axis only, right?
Mhm.
Because at a certain point, the simulation is going to realize that we have this sort of thing.
Mhm.
And then if we had something like this, we'd want it to bounce on the x-axis only, right?
Mhm.
So what I had proposed earlier was that, let's say,
Oh, I see. It's you were suggesting it's previously intersecting on one axis, like
yeah, and
for the approaching from below, it's already intersected on the x-axis, so half our overlap is correct. And then when you get the y-axis overlap, you're like, aha, this is a y-axis delta. So, yeah.
right. So we already have kind of an overlap on the x-axis, right? But we don't
Mhm.
have one on the y-axis.
Mhm. So essentially, we want to run the collision on the previous ball position and figure out which axis was previously yes. And it is kind of return.
Yeah.
It's returning the tuple now of x yes y yes.
You're saying the collision functions return the tuple of x and y
Because it
rather
should,
than Boolean, right?
yeah, because
Yep.
the collision function will tell us that it either goes x invert y invert or both. If we hit the corner and the previous position had no overlap, the current position has both overlap,
Yep.
then we would tell you reverse both directions.
Right. And then the sort of opposite of this. Oh, that was terrible.
Mhm.
Actually, let me do this. Oh yeah.
Dang.
The opposite of this is maybe that we were already overlapping on the y-axis,
Yep.
but the x-axis collision isn't there,
Correct.
right? And then the other edge case that we would maybe run into is that we're not intersecting on either axis, and then we're intersecting, and that would be a bounce on both, right?
Yep. Yep. And having the collision return two bulls lets us do that really easily because the edge case is covered nicely for hitting exactly on the corner. So the physics are preserved.
Correct. And then it does occur to me that maybe there's some complexity if we have how do I get out of that? If we have multiple bricks and the ball like what would happen if this was the current position of the ball here, but then the next position of the ball was here?
Right. So this brick would say reverse y, and this brick would say
Reverse x.
yeah.
Well, we can have it only bounce off of one brick, right? We could say if we've resolved collision,
Just break. We could break. We don't actually need to delete more bricks or if we resolve collision.
Well, I think we want to kill both bricks here, probably.
Mm-hmm. But maybe we take the first return from the resolve function, so we say that this impulse was fine, and we ignore this.
Yeah, well, I think what we really want to do to make it feel good is to know whether or not the brick has a neighbor on that side. And if so, like we basically want to treat it as like one giant brick, these two, right?
Right.
Because
yeah,
it's really not hitting on, it's really not bouncing on the y-axis, like on the vertical edges here, right? It's really not actually hitting that brick on the side. It's hitting it on the front. or on the bottom rather.
So yeah, so we want to know if maybe this is when the bricks become more stronger objects, but the bricks need to have like a edges on or something. I need to know whether or not it is doing edge collisions essentially, or if it's neighbored.
Yeah, if it's neighbor, then that edge isn't valid for collision anymore.
Right.
It basically doesn't exist. That's actually a really good way of doing it.
Yeah,
maybe for now let's not care, but like that's actually a really promising thing.
Well, yeah, because let's write the algorithm for this is the same no matter what, and then when we teach the bricks about each other and improve the colliders to know about the bricks, we'll be able to say like actually like just that's not a collision.
Okay. All right. I'm gonna end my sharing.
Okay. Cool.
Throw it back to you. All right. We have 7 minutes left on stream. I think we can do this.
I think we can do it.
Yeah.
So what the first thing we need to do is we need the previous ball position, right?
Yeah.
And in fact, I'm maybe just gonna take. Well, let's drop some constants in here, which is prev ball x equals ball x. Oops.
When are we creating the ball collision function? We might not even need this, right? Because we get it at the top of every game loop. The previous position is whatever it was on line 114 before 114 runs, right?
Oh.
So basically, under line 113, you can just say let prev ball x equals ball x, let prev ball y equals ball y, and then update those two, right?
Actually. But we do need to have these values outside of here so they can be closed over.
Oh, I see, because ball
collision is just hanging out next to it.
Okay, I see. So that's not inside the function either. Okay.
Yeah, but that's fine.
Okay. Okay.
But now it is updated in the correct spot.
There is a lot of spooky action at a distance happening here.
Yeah, I'm excited to maybe one part of our next stream can be defactor a little bit. Yeah.
Yeah.
It'd be nice to have some classes, like we've got TypeScript, we can use all the bits.
Yep.
Okay, so in this collider, now we've got our ball rect. And so what was it? We wanted to determine, so this is overlap X, yes, overlap Y, yes. We want to know previous overlap X, previous overlap Y, and return a tuple of which one changed.
Yeah, so what we do is the check on line 90 and 91 is correct, and maybe that should be an early out. If either of those is false, return false on both axes, right? Because we haven't collided at all on this frame.
That's if either of these is
so I would say
false.
If not that first thing, return false false. If not the second thing, return false.
Yeah, I'm gonna keep, because we're gonna need this value no matter what. So if not,
well, I don't think we will if these are early outs, right?
Well, I'm gonna say if we check this against the previous one though. So if not overlap X or not overlap and not overlap Y, return.
Or not, because
right.
if it doesn't overlap at all on this frame, then like on either of the axes, then you're done.
Right.
Yeah.
Cool. Something I did. I've broken it. Hang on. Oh. So let's see if. All right. TypeScript lets me do this. X hit Y hit.
Yeah. Well, what is the if there? I think we have to do. I think we need to take it out of the if statement and just do let x hit y hit equals ball collision, and then do if x hit, reverse the x velocity, and if y hit, reverse the y velocity, something like that, right?
Yeah, but isn't this? You know what? This might be Swift. Hang on. You know what? I'll just.
Oh, or is it like pattern matching? Is like if either of.
Yeah. Well, you can do. You can basically drop. You can like destructure into the if clause as part of the like null check or something. And yeah, if either is true, then you're in there. But let's not worry about that.
Okay.
X hit. And let's see. This is going to be did X collide and did Y collide.
Does JavaScript have or equals? It doesn't, right? So you have to do like x equals x or something, right? Because like you could just do did x collide equals did x collide or x hit, did y collide equals did y collide or y hit, something like that.
You can do that, yeah.
This may be golf. Might just be too much. Yeah, we're doing it.
I wasn't enjoying reading it, so
okay.
I think that's a better one.
Okay.
Did collide is not a function. If did y collide. And then if did x collide.
And then in line 145, we need to say if did x collide or did y collide, then delete, right?
Oh, because it's just deleting everything, yep.
Oh no, if x hit or y hit. Mm-hmm. Yeah.
Right, because I deleted everything on the first frame. Thank you. Oh, Lord. I love it. I don't know what's happening, but it's really great.
We can't end the stream before we fix this. We have to fix this.
Okay. Yeah, I agree. So let's see.
Well, our collision function's not done yet, right?
Well, we sometimes return null for one thing. So let's return overlap x, overlap y as our tuple.
And this will get us back to where we were before, right?
I think so, yeah. Great. Ooh, but that one was an x hit.
Yeah, it's because we're not checking the previous position, so we're always going to hit on both axes, no matter what, right? Gotcha. That was what we were trying to account for.
Yep. Cool. Okay, so we've got ball rect. We've also got prev ball rect.
Yeah.
And then we'll do overlap. And then for all of these ball rects, it is now pre-ball rect.
Yeah. And then we're sending back not prev ball x, not prev ball, not prev overlap x, not prev overlap y. That's what our return value is.
Yeah, hang on. Changing this, adding that broke it, which is unexpected. Why is that the case? Oh, prev-ball rect is not defined because I called it prev-rect. TypeScript errors are showing up in interesting ways. All right, great. So this is prev overlap x and overlap x.
Well, overlap x is always going to be true if we get to this point, right? Because we out on that line 92, so we don't need overlap x really after line 92. So I think that line 104 is the array of not prev overlap x, not prev overlap y. We're saying if you didn't overlap on that axis in the previous frame, but you are overlapping now, which we know from line 92 has to be true. Then...
Oh, yeah. Cool.
Is that a double hit there? Seems... Maybe my logic was wrong. That looked good.
Yeah, that actually... This looks and feels... Oh, yeah, that's an X hit.
That should have just... I think that might be the neighbor hit right there where we want to account for the fact that it hits...
Yeah, but I liked the one where it took a chunk out of the second row and bounced away. Like cool. That's the right behavior. So, cool.
Yeah.
I feel we've improved it. Yeah.
Yeah.
This will be interesting.
Oh
cool.
Yeah.
Hey. Great.
Yeah, we probably shouldn't have had an x-axis bounce there. I don't know why. Or.
Actually, we should. What we shouldn't be having is y-axis bounces. You know what it is?
What's that?
So it's as it's coming down, it's hitting the x-axis, and it seems to also be triggering the y-axis because it's approaching from the top, hitting the y-axis. It shouldn't be. It should continue its downward motion. We've built a physics thing where every time it hits this,
it still feels like we're bouncing on multiple axes too often.
Too often, yeah. Yep. Okay. Well, I'm happy to leave it here because the game's not completely broken, and we have improved our collision protection.
Yeah, and we need to do like sick particle effects whenever we destroy a brick.
Oh, of course.
I actually want to see if we can get into like. This is actually not a bad test bed for doing a lot of gamey type special effects as well. We could literally spend the next year of the stream just like making this the sickest breakout ever, which would maybe be pretty boring.
We'll see. I'm interested.
So one thing I would love to do for this is just like camera shakes, where the whole playfield just like gets displaced in like a kind of harmonic way or something like that, and just like make each of these brick smashes like super sick feeling, you know?
Yep. All right.
Okay. Well, have you been watching the stream at all? Has anybody been talking to us? I don't actually have it open.
No one has chatted, but I definitely did not watch to see people chatted. Okay. But 22 people watched this today? That's wild.
Yeah, that's cool. Huh. It's probably all bots, right? We have like Bot Nation watching us.
Oh, delightful. Hello, robots.
I'm fine with bots.
Yeah, whatever. That's great.
Look at us. Make you happy. Oh, that was cool.
Making a breakout for bots by bots.
Really good progress today. So for those of you that do happen to be live right now, we are also archiving this stuff to YouTube. You search for Jeff Dom, it's there. We have a Twitter now that I believe only serves to direct people to our Twitch stream. But
but we can. I've been posting the progress stuff there, so we could always do more. We could put this on a website. We could
do more. Our like meme game could be better. You know, like we could. We could be doing a lot more. We could get political on our Twitter stream, right?
Oh, I mean, you know, is this a breakout game about seizing the means of production by smashing through a wall?
Oh yeah. I was actually kind of hoping to ask you about Tom Nook and your view that he is proletarian. But
of course he is. Yeah.
I think we could save that for the sort of debt collecting real estate magnate Tom Nook is actually like closet communist.
Absolutely. I don't know about the stock market bullshit though. The stock market seems to be entirely a capitalist way to make my poor villagers part with their money.
Does he run the turnip exchange?
No. Totally external party. So someone's trying to bring a market to my island. And
okay. So the claim about Tom Nook is still
valid. Yep. Okay. But I am participating in this market, and his children run it. So I don't know.
Yeah.
Nepotism, you know.
Yeah, the kind of dynastic sort of apprenticeship sort of thing. That's not totally out of line with the sort of. I don't know. All right, we'll talk about this later. We'll dig like the early marks out.
Episode 3. Politics.
Episode 3. Yeah. Okay.
All right.
Well, thank you everybody for joining the stream. Thank you, Dom, for driving this time. You did a much better job than I could have.
I think our jobs were both equivalently excellent. You wrote the jail code last time. I can't do that for shit.
All right. Take care, everybody.
All right. Signing off the stream. Au revoir.